All right, so I pulled the little like screenshots of those 1, 2, 3, 4, 5, 6, 7 postulates that we needed to know from yesterday. You do want to know the names of those postulates and what they say. After we're done with this little bit of review, I'll give you the link to the Quizlet that has all of that stuff, plus the stuff from 121 and 22. You want to make sure you know everything on that, obviously, in addition to how to apply it.
If you do, should you get 100 on the quiz?
If you know all of that and you can do like all this, like all the application of it, yes. Number 1 says use the diagram to write an example of postulate 2-3, which is called the line intersection postulate. The line intersection postulate says if two lines intersect, then their intersection is exactly 1 point. So, Sophia, what's an example with the letters that are there?
I put line EG intersects line FG at point F.
EG, that's so sloppy. EG intersects.
There's a portion like that on the quiz.
Line, you said FJ?
Yeah.
At point F. Good. You could have also said what for the line names? Line N and line M intersect at F. Okay. There, you could call them any combination of those letters. EF, line EF, and line JF intersect at point F. Like any of those would have been fine. Number 2 says to decide whether the statement two planes can intersect at exactly 1 point R is true or false and give your reason.
False.
And why?
Because planes intersect actually line.
Good. False. Planes intersect at a line, which is the plane intersection postulate. Okay?
Would I have to have said that it was plane intersection postulate?
No, but you will get a statement or a diagram, kind of like what we had the examples yesterday. And there will be multiple choice of which one it is, and the multiple choice is going to be the names and not the description. So just make sure you know what the names are.
So is the quiz going to be all multiple?
No. Part, yes, not all.
What wouldn't be multiple choice?
Like random questions. So not the ones where you, but like, can you do the inverse? Can you do the converse? That could be, yeah, that kind of thing. All right, number 3, 4, and 5 are based on the diagram. It says use the diagram to determine if the statement is true. So this one says the intersection of planes M and N is points B, E, and H. True or false? Trick question. What's the intersection of two planes? A line. So this is just a listing of points. It would be false because it would be line BH or line BE or line EH, any of those, okay? But this is the line. So the intersection has to be a line. Yep. No, because one's going this way, like they're crisscrossed. So one's going forward and back and one's going up and down. Where they meet is where the intersection would be. Mars.
I want to do the next question.
Oh, okay. So the next question says GH, which is this line here, lies in plane M. True or false? True. Good.
Do you have to explain why it's true?
No, only if it's false. Actually, it just says is statement true or false. So you wouldn't even have to explain. If it said explain why it's false. And then 5 says ABE, which is this angle here, is a vertical angle to HED. True or false, Sophia?
False.
False. Okay, the vertical angle to ABE would be this angle here. And the vertical angle to HED would be BEF, if you wanted to give a vertical angle. They do not make an X, right, which is why they're not vertical angles. Okay, so tomorrow's quiz is 10 questions, okay? It is strong on the vocab this time. Obviously, there's no arithmetic, right, because a lot of this is logic. So from 2-1, and all of these are on the Quizlet. I repeat, there's a Quizlet, and all of these are on it. Okay, what is a conditional statement, which is your if-then, right? In symbols we did, this would be P, then Q. From there, you'd want to identify the hypothesis and the conclusion.
Can I read this?
Sure. Okay, the hypothesis, it was what follows the if. The conclusion is what follows the then.
Wait, where is the conclusion?
I didn't publish it yet.
Oh.
The converse is the reverse of the order. So it'd be Q, then P.
Lisa, where do we write this stuff from?
Anywhere you want.
Oh, okay.
The inverse is the not P followed by the not Q. So we negate both the if and the then of the original. The contrapositive is the combination of the two. We switch it and negate it. So not Q, then not P. The negation is the opposite. So if I said to negate there is a Quizlet, it would be what?
There's not.
There is not a Quizlet. The biconditional is your if and only if. Which means that both the initial and the converse would have to be true. This is usually used for like definitions. Like we said, an angle is a right angle if and only if it is 90 degrees, because that is true in both directions. And a counter example is something that makes the if is true, then is false.
If it's true.
No, like the if part of your statement is true. So the if, like as in the if part of your statement is true, but the then is false. So like if your teacher tells you there's a Quizlet, then everybody knows there's a Quizlet. You would be the counter example on that, Santi. Because I did say there was a Quizlet, but he did not clearly hear me say that, right? So if you're a McCarthy student, you're wearing all black shoes, right? So then what happens if you're not wearing all black shoes? You're still a McCarthy student, the if is still true, but the then might be somebody that's not wearing all black shoes. Questions on 2-1. All right, 2-2 was the inductive and deductive reasoning. We learned that inductive reasoning is based on patterns. And observations.
Wait, what was counter example again?
Something that makes the first part true, but the second part false.
Okay.
A conjecture is a decision made based on inductive reasoning. So every day the lunchroom sells pizza, and so you assume that you walk in there tomorrow and they will have pizza, but what happens if it's breakfast day and they don't have pizza? Okay, that's an observation. That's a conjecture based on inductive reasoning. Deductive reasoning is based on facts or definitions. Like a number divisible by 6 is also divisible by 2. Okay, every number that's divisible by 6 is also going to be divisible by 2. Okay, that would be something that's a fact based on a definition. The law of detachment is one if-then statement in which the if occurs again, so you assume the then is going to occur. So it only has one if-then statement. If it rains, then the grass floods. Okay, and it rains.
Grass.
Floods. Yes.
Wait, what?
So a law of detachment says there's an if-then statement. So like if it rains, then the grass floods. And then the if occurs, so you decide based on that, or you make a conjecture based on that the grass will flood.
And then if it says it doesn't rain, you put the grass doesn't flood. Or almost.
No, you can't. We don't want to. You want to go straight off of what the law. What you can't determine is what you can't say, like, and what they try to do is, if the grass floods, then you know it rained. Well, that's not true, right? Because it doesn't necessarily. You don't know that that's why it is. So the if has to occur again, not the then. Okay. If I give you that the grass floods, you could have another reason. It could be the sprinkler head broke or a hose ran, something like that. There could be another reason why.
So like,
You can't assume the if happens if you're given the then. It can only be the if that's given again. The law of syllogism has two if-then statements. If it rains, grass floods. If grass floods. I'm going to say that we ruin our shoes.
grass floods.
So that's our initial statement, and then it rains. So what does that lead us to believe? We're going to ruin our shoes.
Grass floods.
We take out the part that repeats. Gabriel.
Can I go down?
Okay. And then 2, 3, which is what we started with. Those 7 postulates, okay? That would also be on your quiz.
Wait.
All right, I'm going to go over it. So if you're still working, you can check while I go over it. So
Is that supposed to be graded?
Did you grade this?
I just gave stickers fast if I could find it.
Is the quiz review graded?
No.
Intersection.
Okay, so most of you did this correctly, okay? And I base it off of like your if then. So if your if then is a little bit different, it's okay. But I put if you are, so that would be apostrophe RE. If you're a McCarthy student, then you dress up for homecoming week. So that would be an if then statement. Converse, switch the order. If you dress up for homecoming week, then you're a McCarthy student. Inverse, negate the original. If you're not a McCarthy student, then you don't dress up for homecoming week. And contrapositive is the blend of the two. If you do not dress up for homecoming week, then you're not a McCarthy student. The conditional, okay, and the converse are both false. You're not guaranteed. If you're negating the conditional, then you could be a McCarthy student that does not dress up for homecoming week. And if you're negating the converse, then you would be somebody that dresses up for homecoming but does not attend Archbishop McCarthy High School. Could be any other high school. Okay, somebody put a teacher also dresses up, so that makes sense. The second slide said write a biconditional statement. So the if and only if should go in the middle. It should say today is Thursday. If and only if tomorrow is Friday. If you put today or tomorrow is Friday, if and only if today is Thursday, that's also true. That's okay. Okay. But you have to have the words if and only if. This one said use the law of detachment to make a conclusion. So if you study for the quiz, you will do well, and you study for the quiz, your conclusion is what?
You do well.
You'll do well, okay? The law of syllogism says make a conclusion of if you study for the quiz, then you'll do well. If you do well, you'll make your parents happy. You study for the quiz, so
Your parent happy.
your parent happy. You'll make your parents happy, okay? All right, let's go.